Hello. In this code includes several text functions support building, training and evaluating deep learning models using TensorFlow and Keras libraries. It also validates model structures to ensure the correct layers and parameters are applied. Libraries used in TensorFlow and Keras used to define, train and evaluate deep learning models. NumPy used for numerical operation and accuracy testing, and the code provides functionalities in three main categories. For the first one, error calculation tests validates metrics like mean, squared errors, and categorical error rate. Model structure validation test whether different model architectures are correctly built. Regularization validation ensures proper implementation of L2 regulation parameters. And for the first one, the detailed explanation of function and test definition of test eval MA's targets. This function tests whether a given target function correctly calculates and means squared errors, and the purpose of this function verifies that the mean squared error between y hat and the y temp is calculated using the formula is 1 divided 2 times m times and sum of the y hat minus y temp squared 2. Error between different values and zero error when all values are equal. Correct computation for large differences. Expected output is if all tests pass, the output is all test passes, and this function verifies the accuracy of a classification model's categories error rate calculation. And yes, this function verifies the accuracy of the classification model's categorical error rates calculation. Purpose of the function ensures the error rate between y hat and the y temp is computed as formula. Test scenarios full error when all predictions are wrong. Partial correctness and its effect on the error rate. Correct handling of multi-class predictions. This function validates whether a deep learning model has the correct structure. For the purpose, check the number and types of layers, validates input and output dimension of each layer, ensures proper activation functions, confirms the optimizer, and learning rate verifies that the last function is spreads categorical cross-empty with the from logits true. And expected structure: first layer 120 neurons relay activation, and second layer 40 neurons relay activation, and output layer classes neurons linear activation. Model as target classes input size. This function tests a simpler model structure similar to model test but with 2 layers instead of 3. First layer 6 neurons and relay activations, and output layer classes neurons and linear activation. Model R test target classes and input size. This function validates a model with regularization parameters. And for the proposed, check for L2 regularization in the first 2 layers. Ensure the L2 regularization factor is set to 0.1. Expected structure: first layer 200 120 neurons relay activation L2 regularization. The second layer is 20 neurons relay activation and L2 regularization. Is the how to code works. And is this line how the code works and defining the target function. This user defines the target function to be tested. For example, an mean squared error function and def and sorry. Okay, sorry. And the test eval MAS model test after the defining model structural validation is performed. Model sequential and dense 120 and activation is relu and model compile optimizer equal to Adam learning rate is 0.01 and if loose sparse categorical cross-entry from log it's equal to true. An application of the code training process validation ensures metrics and the loss function are calculated correctly. Model error check agriculture verification confirms that layers are properly defined. Regularization check validates correct implementation of parameters like L2 regularization, improving training efficiency, quickly identifies error to optimize the training process. Example workflow mean squared error test. Define a simple function to calculate MSA and yes, and test eval MAS model validation. Define a neural network model. For model minus sequential dense 120 and yes, this one. And for expected 120 it's equal to relu, and the second line is the dense 40 relu activation equal to relu, and second one is 10 is the non-activation equal to linear. And with these detailed explanations you can create a comprehensive each part of the code step by step. I did, and I saved the showing how it works and why it's used different scenarios. Using examples for the errors will make the content engaging and educational. And for the I can try to understood this part. 2 layer instead of 3. The first layer is 6 neurons relay activations. Yes, this one. And the output layer is classes, neurons and linear activations. Model R test target classes input size. Yes, this one. And the purpose of the check for L2 regularization in the first 2 layer, this and this. And expected layer classes neurons linear activation and no regularization is this part for E equal to 0. And for the purpose and training process validation ensures metrics and loss function are calculated correctly, confirms that layers are properly defined, mean squared error test defines sample function, calculate the mean squared error, and with that detailed explanation I can create a comprehensive explain each of part the code step by step, showing how it works and why it's used in different scenarios, using example for each test and demonstrating how to fix potential errors will make the content engaging and educational. Thanks for that.